we're recording. Okay, go.
Wait, what just happened? Oh, yeah, okay. Yeah, so checking code is which base in all caps. Yeah, check in for your free points. All right, let's get started. So last time on Hack School, we went over Express, which is just like web application framework for Node.js. And you could essentially create your own API routes, and it abstracts away the complexity of serving a web application. So you can essentially like be able to, it does most of the like heavy duty stuff for you, and then all the behind the scenes stuff for you. So you could set up stuff really easily. Um, so creating API routes, we went over how to make GET requests. So in this example, we're going to get a Pokemon from the database and return it. Similarly, we also have post requests. This is used to modify data. So you could pass data from the body of the request and do something with it on the back end. So that's pretty much it for last time. We also did React stuff as well, right? Yeah, okay. Cool. So this time we'll be going over databases. So what exactly is a database? Any takers here? Any wild guesses?
It's a base that stores data.
Yes, that's very good. Yes. So more formally, we can describe a database as just an organized collection of data or information. In other words, a base that stores data. So so why do we need a database? So we need to store and persist information between sessions. So if you store stuff in like a React state or just in like JavaScript, that's not going to be saved when you refresh the page, right? This also provides us a way to organize our data in a logical way. So whether it be SQL or NoSQL, we'll get to that later. This lets us essentially organize our data in a way that makes sense to us rather than just having like random bytes everywhere. So in the context of our Pokemon generator, this lets us store and view each Pokemon we create. So that's how we're going to organize data, is by each Pokemon in the database. Don't worry about that. Okay, so organization of data. So there's different ways that databases organize data. So the two most common are NoSQL versus SQL databases. So SQL stands for Structured Query Languages, and it uses what's called a relational database, which means tables to organize information. So everything's stored in tables with rows and columns specifically for your data. Whereas NoSQL databases are non-relational, and typically data is organized as documents. And here I have some examples of different SQL and NoSQL databases. So MongoDB and Firebase, for example, are very well-known NoSQL databases. And here we have different types of SQL databases. So this is PostgreSQL, I think. This is MySQL, SQLite. So yeah. Anyway, so in MongoDB, data is stored in collections, and these collections contain documents, and each document contains a key value pair. And you can think of each document as if it was like a JavaScript object with key value pairs. And key value pairs can be like pretty much any type. They can be like numbers, strings, images, like any type of data you want. They could even be other JavaScript objects. So this is like a visual representation of what the data would look like. So you have collections of documents, and a bunch of these collections will make up a database. And notice that each document is its own JavaScript object. So as you can see here, we have, this is, I guess, like users in a database, for example. So name, age, status, these are all keys, and these are all the values. So these are like, for example, this is a string, this is a number, and this is an array. So yeah, they can really take any type of data. Yes, this is like the picture in your head you should have. when you're dealing with MongoDB and other types of NoSQL databases is this document collection database kind of model. Anyway, so let's start by setting up our database. So for this, we're going to need to go to MongoDB Atlas and create an account. Oops, did not mean to do that. Okay. Let's see. Yeah, so I'll just walk you guys through this process of creating an account and creating a database. You could just log in with Google. So just accept.
Let's wait for like 1 or 2 minutes, just so everyone gets like the link, and like
yeah,
once you get onto this page, we'll continue.
Yeah. Okay. Yeah,
I'll
the
link
link
it in the
is
chat
right
as
here.
well.
Oh yeah, that's good.
Oh yeah, Andrew got it.
As a side note, you can also run MongoDB locally. That requires you to install it and set it up yourself. So it's a little more work to do. So this is an easier way to set up MongoDB on the cloud with MongoDB Atlas.
To answer Julie's question in the chat, recordings of these will be posted on YouTube. Yes, Jacob got the link. Jacob's such a loyal fan. So if you haven't, just like, comment, subscribe to the Hack School video. No, you don't have to actually do that. But you can subscribe and get like all of our events on our the general ACM YouTube channel. It's all there. There's a playlist as well.
Smash that like button.
React to the videos. Okay.
All right, we can probably continue.
Okay, cool. I'm gonna assume everyone is like at this page, or is ahead. So organization, you can call it whatever you want. Project name, this can also be whatever you want. I'll just say Pokemon generator because it makes sense. We'll just select JavaScript as our language and go. Okay, so we're just going to use the free plan because we don't want to spend money, and because that's perfectly fine for our use case. This really doesn't matter. Just pick the region that's closest to you. And all these settings should be good. Oh yeah, you can change the cluster name if you want to, but that doesn't really affect anything. So yeah, I'll wait a little bit for people to reach this stage because it will take a while to create the cluster.
Can people like either type in chat or like react with a thumbs up when you get to this point?
Oh yeah, that would be helpful for sure.
I know like naming the name of the cluster doesn't matter, but like how would you name clusters so it's like easily identifiable for what it is?
I don't really have a naming convention that I like to use. I don't really know what the convention really is.
Okay.
But yeah, I would just usually name it like after the project. Either that or the region it's in. If you have like multiple clusters in different regions.
One thing you can do as well, if you ever make like a project that's like going to scale, you might want to have like multiple clusters or like multiple databases. And when in that case, you can put like dash dev or like dash production or dash staging or whatever to signal different stages. So like you have like a testing database and you have the production database. Those are some ways you can kind of change up. You can kind of name your clusters differently to associate this. Yeah. But in this case, it doesn't matter. We just have one. So
Yeah. There aren't really any rules for naming. It's just like whatever is descriptive.
Right. Like what's in the cluster? Like what is it? Like how would you give a descriptive name? Like because I don't know what a cluster is. So I don't know how you name it so it's descriptive of what it does.
A cluster is basically just, think of it like, it's like a bunch of databases. You can have multiple databases in a cluster. So it's like the next level up in the hierarchy.
Okay.
And it'll all make more sense once we like actually create our database and start inserting things into it, which we'll do next.
It's like watching paint dry. It's fun.
oh boy. How long has it been? Like 2 minutes?
Okay, I think it just finished, or it's about to finish.
Right?
Okay, so it looks like it's up for us. I'll just wait like a little bit because I know some other people are probably still like creating their clusters. So, but the next step is you would click connect and you would add your IP address here. Yeah, I'll just wait a little bit. Actually, could you guys react with like a thumbs up if your cluster's done? Because I don't know how long it's gonna take for everyone. Okay, looks like I'm getting a few thumbs up. Okay, I'm just gonna move on here then. Okay, so the next step here is we need to add our IP address. This is so that like we can't just have anyone from any IP use our database. This is like another security feature. You can add your current IP address or you can just allow access from anywhere. So it's probably best to do that. Oh, you can see my IP, whatever. I don't really care. Yeah, so if you want to DDoS me, that's fine. Anyway, the next step here is to create a database user. So this is what's used. This is like another layer of security for your database. So let's say someone gets a hold of your link, right, to your database somehow. They won't necessarily be able to access all your data if they don't have the username and password associated. So you can just call it whatever. I usually like to use admin and then just generate a random password. So you want to save this password because this is important for later. Then we're going to click create database user. And so now we're done with this first step. So now choose a connection method. So it gives you the link to your database right here. And so we're gonna need to copy this database link and use it in our code. Real quick, I'm just gonna paste my password somewhere so that I could use it later. And then I'll copy this link. If you want, you can also see this code. This code isn't really useful to us because we're using Mongoose. But yeah, this would be useful if you weren't using Mongoose and you were just using MongoDB in your Node application. So we'll just copy this and close. So real quick, I just want to walk you guys through this interface. So if you go to collections, you could see, okay, right now there's no data in the database. So let's start by adding our data. And a database name, we can call it whatever. Could you go through that last process again? Yes, sure. So you click connect right here. And let's see, oops. You have to add your own IP address to this, to the whitelist, essentially. So that would normally be done here, but it looks like we could also do it here if you have multiple IPs, for example. So it would autofill with the current IP automatically that you have. So you don't have to worry, you don't have to like know what your IP is for this to get filled in. And then you need to create a database user. So you just specify a username and a password. The password can be anything. The username could be anything. I went with admin usually because the first user you create has admin permissions. And then I just auto-generated the password. So we look here, this is the, here. You can create another user if you want. But for now, we could just stick with one user for this project. So yeah, does that answer your question? Okay, connection method, that's here. You just click connect to your application. And that will take you here. And this is the link you need. So you need, in addition to this link, you also need the password to your database, and you'll paste that in later. But this is the important link that you'll need. Yeah, so this database, you can think of this as like another server hosted somewhere else. And we're connecting our server to this database. Yeah, Shravan pretty much described it pretty well. Okay, so just gonna copy this. All right, so I assume everyone's good then? Getting a few thumbs up. Okay, so I'll go over this interface a little bit. So if you click add your own data, you could create a database and a collection to start with. So we'll just create one, call it like Pokemon or something. And then collection. I think Mongoose is gonna handle collections and stuff for us, but this is just like a good way to like experiment and play with MongoDB just to get used to it. So yeah, your documents that you put are gonna show up here. So we could try inserting a document, for example, with like fields. And it'll show up here when we insert it, basically. In the future, we're going to be doing this from Express, and we're going to be doing this automatically. So we're not going to be manually entering data. But this is just what the interface looks like. So yeah, let's get back to the presentation then. So that was this step here. The next step is we're going to have to set up Mongoose. So this Mongoose is a wrapper for MongoDB to be used with Node.js. And it's used to define schemas, which are essentially blueprints for the structure of our data. So this is important because unlike a SQL database where we have like predefined columns and fields, the documents can take really any structure. So the issue is that like you might have different documents with different structures in the same collection, and that could pose an issue if you're reading some fields that don't exist, or you have extra fields with data. So essentially Mongoose attempts to define like a set pattern that your data must follow. So the schemas we use are going to be used to generate models, and each instance of a model is going to be a document in our database. So you can set this up by typing npm install -- save mongoose. I think you don't need the save, but I just typed that out of habit. But this essentially just saves it to package.json. Yeah, schemas are equivalent to classes. You can think of it like that. So schemas are like classes, and or maybe abstract classes or interfaces. Models would be classes that implement them, and then documents would be objects that you create. So if you're used to object-oriented programming, that'd be a pretty good analogy. There's some construction going on. I apologize for the background noise. Anyway, so are we all good on this slide? All right, cool. So connecting to our database. So we're gonna have to now connect our server to our database. And we do that by copying the URL from Atlas that we generated before. And we're gonna store it in our end file. And this is the code to connect to the database. So we're going to essentially put the environment variable into the config file and then refer to it here. So I could do a bit of live coding, I guess. So this is our code from before, from last workshop that we left off at. And I'm going to create a .m file. And so the variables we're going to need are database URL, and that's going to be this. Oh yeah, the port should be defined as well. So this is our database URL. The password here, should we replace the port or just type after it? Yeah. So what I did here is I just kept going on the next line. Password here is going to be the password that we used before. Oops, that was not what I wanted to do. Okay. And then DB name was whatever database name that you created. So in this case, we call it Pokemon. So we're just going to use that. So then let's see. The next step here would be to go into our config file and essentially define this. So this would be config.database URL. We just do process.env.database URL. All right, so now the next step would be to essentially call this code in our index.js for a server. So I think I need to install Mongoose because I haven't done that yet. Okay, and then we're going to call it here. So const mongoose equals require mongoose. And then we're going to, according to this code, initialize it. And also call our config. So I'm just going to copy this because that's 95% of software development. And we're just going to paste. For aesthetics, we're going to just move this up here. Oops.
Oh, wait, real quick. I think you already have the config defined. So
Oh,
you don't need that.
okay.
Yeah, it's already
I
up
noticed
there.
that. Okay, perfect. Thanks for that. Yeah, so this is what allows us to connect to our database. Mongoose.connect config database URL. So this essentially connects us to our database and we're chilling from there. You don't have to worry about these parameters here, but this just makes it so that it works. All right, is everyone good on this step? I'm just gonna wait a bit for. Okay, question. Did we have to copy the first, so on this slide? Yes, you need this line. Turns out we already have this line in our index.js file. So just this one is the one we need. In fact, I'm just going to delete this because it might be confusing. Okay. So the config code simply extends from the .env file. So we did this last workshop, I believe. We added the port. So const.env, so this creates the .env, this essentially imports that and then configures it so that we can actually use the variables in that file. And then this just simply assigns, the variables to this object here. And the reason why we do this is that we can simply refer to this object config.whatever instead of doing process.env. It's just slightly easier to do it this way. So yeah, this is the config code, and then this is the actual code to connect. Okay, is everyone good here? To connect to MongoDB. copy paste this code. Yeah. So once you have your config file defined and your .m file with your URL defined in it, you can simply just copy this code. Okay, so are we good to move on then, everyone? Okay, I got one thumbs up. Yeah, so it's always a little bit too confusing. It's understandable. Like I just kind of did a lot there. But yeah, feel free to ask any questions in the chat if you have any, if you're still confused. Yeah, okay, I guess we'll move on from this step then. So now that you have connected to your database, we're going to start defining schemas. So let's first define what a Pokemon is in our database. So what does a Pokemon need? Well, it needs a name, a description, an image. Pokemon could have up to 2 types and moves as well. So move is going to be defined in its own schema, so we're going to work on that later. But for now, let's create a schema. So we're going to go into here, and we're going to create a new folder. Call it models. Pokemon.js. So the syntax for creating schemas goes like this. So we first need to import Mongoose. Then the next step is we're just going to define the schema here. We'll call it Pokemon schema to be descriptive enough. Is my dark mode too hard to read? I'm sorry. I'm just going to zoom in a bit. Okay, hopefully this is slightly better. Okay, so then we're going to have to define our schema here. And this is done with the object or the class schema. And this is just going to be a JavaScript object, basically. So we're going to have a name, and this is going to be of type string. And we have another parameter require. And this defines if the parameter is required. So all Pokemon need to have a name, so that's true. And the next one, description, is doing most of the same here. So string require true. Image. Oops. So this is a type, true. And the next one here, type 2. So not all Pokemon have a second type. So we're going to make require false in this case. And finally, we have moves. You don't need commas. So here I didn't put a comma. Usually I prefer to put commas simply because if you want to add stuff later, it's much easier to just start typing rather than having to think about inserting the comma. But you don't need the comma. Yeah, it's just different.
One quick thing, sorry. It's supposed to be required, not required.
Oh, oops.
Yeah.
I'll just dang. Should be fixed. Yeah, so the moves, we're going to fill this in later because we need to define our move schema first. So then the last step here is now we need to create a model based on this. So based on our schema, we're going to create a mongoose.model. And this is going to be based off of this schema. And we're going to pass this in as the schema there. And then we can finally end this off by exporting our model. So think of this as essentially defining an interface or a class, and then just exporting it. So I'll just leave this up for a little bit. Oh, so moves is blank because a move is going to be its own schema that you guys are going to write later. So right now I just have it left blank, but I'll just add a to-do here. No, schemas, I mean, you can if you want, but I think it's typically better to separate them out. So Pokemon.js is going to be one schema, and then we're going to have a moves.js to be another schema, or move.js, I guess. Yes, code organization. One important thing to think about is you're writing code not for computers, but you're writing code for other humans to understand.
Yeah, your laptop's not gonna die, right? What do you think that
No, okay. This is so weird. Look at my battery.
Okay. Okay. I'm just like, wait.
I swear, this makes no sense. It's been plugged in 94 and it says low battery, but it's not going up.
So funny.
Just don't worry about it.
Can you go over I think Jacob needed to create a Pokemon database if you wanted.
Oh, right, sure. Hold on, my taskbar doesn't exist. Oops. Okay. Okay, I'll delete the database. I'll recreate it. So you're going to click add my own data and then provide the database name. Collection name, I think Mongoose handles collections for us. So you don't need to worry about this, but it still wants you to create one. So I just put a filler name like test. We're not going to be using this collection, but this database is what's going to hold everything. So yeah, this is our test collection within the Pokemon database. And the name of the database here is going to be used in, let's see, in your .m file. So it's going to be here. And this is the username and the password that you generated at the very beginning. Okay, cool. I'll leave this up for a little bit more. How's everyone doing on this part? Okay, got a few thumbs up. So this is the Pokemon schema that we just defined. So we're going to move on now. So the next step here is you guys are going to define the move schema on your own. So this is going to be very similar to the way we define the Pokemon schema. One key difference is that we're not going to be creating a model based on this because we're not going to be storing moves themselves in the database. Each Pokemon is just going to have its own moves. So yeah, this is just a quick coding activity. So a move has a type, a name, and a power associated with it.
We could probably hop in the Discord.
Yeah,
voice
definitely.
chat. We'll do this for like 5 minutes.
Yeah. Also, if any of you are new and aren't in the Discord for whatever reason, just like text in chat, and I'll add you. Okay.
Are we good to move on?
We're almost done here.
All right.
Yeah. Okay. Are you ready to keep going?
Yeah. Should be almost done here. Hold on a sec. Okay. Looks like we're good here. So this is the code here for the schema. So this is pretty much the same as Pokemon, only there's just less fields. So for type, we have string. So this is the type of the move. The name of this name of the move is also a string. The power of the move is going to be a number. And we're not creating a model of this because we're not going to be creating documents of moves, right? We're just going to be using this structure in the Pokemon itself. So we'll be directly exporting the move schema. And then inside of Pokemon here, we're going to import move schema from move. And for the moves part, so Pokemon can have multiple moves. So we want this to be an array of, there's going to be an array of moves. So for type, we're going to make this move schema. And well, all Pokemon need to have moves. So we're going to make this true. So that's pretty much it for this step. All right, anyone have any additional questions?
So did that just create a like is moves now like a variable length now or something, or like how would you create multiple moves?
So I put it in this bracket, meaning that this is going to be an array. So the type is an array of move schema.
Okay, and then required true is satisfied as long as type has at least like one element. Is like if you wanted only to input one move, then required true would still. Like,
yeah.
Okay.
Yeah, I think the required true for moves is just implying you can't have 0 moves.
Yeah,
and then
exactly.
Is there a max limit though? Like if I wanted to create a Pokemon of 6 moves, is there anything stopping me from doing that?
Not the way we have it now.
Yeah.
But there are definitely Mongoose specific syntax to limit that. I'm sure. I just don't know what it is off the top of my head. I don't know if Garrett, if you know what it is off the top of your head.
I don't really know either, but yeah, there definitely exists some like way to limit and further like constrain the structure of things. So yeah, this is the code for moves. So I'll leave this up for a little bit in case you guys didn't finish. Oh, that's a nice link, Stack Overflow. Okay, I guess we're good here. So we're gonna move on, unless anyone still has questions. All right, so the next thing we're gonna focus on are the main operations of a database. So these are known as CRUD operations. So create, read, update, and delete. And this is how you're gonna be interacting with the database. And for this project, we're only gonna be using the create and read operations. So create is to create new documents and read is to get documents from the database. So going here, create is used to add new documents. So we create a new document from a model with the specified fields. So this is an example here. We're going to create a new Pokemon called Pikachu. I didn't write the rest of the fields because that would take up too much space. But then you would just pass it in here, Pokemon.create new Pokemon. And doing this will create a new document in the database with the specified fields that you give it here, according to the model that you defined. So we have this, and then we have read. And read allows us to get data from our database. There's also other ways to do this. So you can run pokemon.find.exec. I'll explain what the .exec means a little bit later. But this gets all the database, all the entries in the collection. So every Pokemon in the database, and returns it. And then you have other types of queries like find by ID. So you could find Pokemon by ID. We're not going to be using this in the project, but this is just an example of other things you could do. And there's definitely more advanced queries you could do. So that's what this exec really represents, is you can actually chain like a bunch of queries. So you could say, like, you find all Pokemon where the type is electric and the name is like after a certain character or something like that, right? Or like the number of moves is 4. And you can chain a bunch of these queries, and then at the very end, you're gonna add an exec there to actually execute the query. So that's what that means. So this is just the basic read and write operations that we'll be using. And so the next step here is for you to populate the routes that you wrote in the last workshop. So if you remember in the last workshop, we defined the Pokemon route to be just returning a fixed object or a fixed array of data. And same with post, right? So this time we're going to be actually using our database to make these routes work as they should. And finally, we'll be testing the routes out, creating documents and reading documents with Postman, just to see if they work. So yeah, we'll give a little more time for this because this will take a bit more time.
It was discorded up.
Yep.
The remaining 40 minutes we have is kind of just flesh out the view Pokemon page and just finish that whole view Pokemon aspect. And then next week, we'll be finishing the whole create Pokemon page. So today, so this like the next 40 minutes is going to be a lot of like live coding stuff. So like try to keep up, and like if you have any questions, you need me to like repeat something, just let me know in chat. Okay, so just to go over a little bit of what we went over last time, since I know I think also around this time we were a little rushed. We went over React State, which React State is just the idea of how a component is like really dynamic. and you can keep track of the current status of a, you can use them to keep track of a current status of a component. And then whenever state changes, the React component automatically re-renders. So that's how, like, if, for example, you have like if you had like a time component, for example, and like the hour changed or the minute changed, if we change the state, the component will re-render automatically. And then we don't have to deal with any of that stuff. Oops, I have to, wait, okay, there you go. So, but how do we change state? And we have a bunch of event handlers in React that we can use to like trigger a state change. Some of these include onClick, onChange, onFocus, onBlur. We'll be going through this a little bit in the live coding portion as well. Yeah, so this is an example. So you can import this thing called useState. You can declare a state like this. Basically what this notation is just means that clicked is our variable, set clicked is a function. Why we do this is just because that's just how React is. So we kind of just have to deal with it, but that's how you declare states. And so if you want to change state, you just call set clicked, kind of like what we did here. And then onClick was an example of an event listener to change the state, to trigger a state change. Okay, so let's finish our activity from last week. So ignore this link for now, actually. Okay, so wait, let me just delete this actually. Okay, so correct me if I'm wrong, but I think this is what everyone's view Pokemon should look like, right?
Can you zoom in a little bit, please?
What's up?
Can you zoom in a little bit?
Oh yeah, I can do that a little bit. Wait, nope, that's zooming out. Sorry. Okay, let me know if this is good. It's good.
It's better.
Okay. So I think this is just your view Pokemon page might look something like this. And so, yeah. And so for the activity last week was we just had like an API.js file, and we kind of declared the get and post request. And so I believe we didn't. So we can kind of showcase how states works a little bit here. So what I can do is I can make like I'm just going to show an example of like how state works. So we can make a little we can make an example state here called like example, for example. Let's just say it's like a little string. And then we can have this button that has an onClick that will call a log Pokemon function, which I will define right here. So I'm going to do log Pokemon. And then let's just say, for example, that like we kind of want to just like append an A in our example state, right? We can do example plus A, and then we can actually we can just do, yeah, we can do that, and we can do like do something like this. Start. Oh, what the? Hello? Oh, is it yarn? Oh, I know that. CD client yarn start. Give me a second.
npm start also works.
Yeah.
Yarn is just another package manager.
Oh yes, my bad. Let's go to view all Pokemon page. So we have this log Pokemon button. Oops, wrong thing. Sorry. Inspect console. Zoom in a little bit. Okay, so if I click the log Pokemon function, yes, you can see the state changes over time. So we have A, which is basically what we kind of wanted, right? So we can kind of reframe this a little bit to match what we want here. Let me find something real quick. Give me a second. Okay, so Yeah, npm run start. Okay, so I think the activity that we left off with last time was to call a GET request to our server and do something with the body, and eventually we're gonna populate the view Pokemon page with that body. And so I'm gonna delete this because we don't really need this anymore. I would just comment it out. But essentially we can define body here and use set body. It goes use state. And so what this body is going to represent is the body of our GET request API. And so keep that there. I'm going to count that out. And so in order to make the GET request to our server, we're going to need to do API.getPokemon, and then we can do .then, which means after we get the GET request, we will, we're going to get our data. Or sorry, let's do response here. And then we'll set the state to be response.data.Pokemon. And then we can just log this body, right? So this would be like the the simplest form. This is like the simplest way we can do it, right? So let me go ahead and start the server. I don't think I've done that yet. Start. Okay, so we have our server hosted on port 5000. So if you haven't done so, go ahead and just start up your server. Right now, I have like the example data from last time. So my data might look a little bit different. But let's say we hop onto here and then we try doing this. Okay, so we're able to get the Pokemon. But I think, one thing I really want to point out here is like, notice how laggy it is right now on my end, right? Let's see here. Yeah. Let me actually try to do it. Let me actually make a HTML type to kind of showcase this a little bit more. We could do something like this. Give me a second. We could do something like this. It might work. Yeah. So right now, what's happening is I'm trying to load like my page, but as you can see, it's like getting really laggy, and it's not as smooth as like it just was earlier, right? Just like a couple of seconds ago. Like right now, it's like it's barely loading. Like this spinny circle is taking a long time. We have like an object thing here, and so you might be wondering like, why is it so laggy? Like why is it like not working? And the issue comes from how we're calling API.getPokemon like in the component just like this. If you remember from last time, I forgot to cover this in the slides, but we went over a hook called useEffect. And so I'm just gonna paste it in here and I'm just gonna take it out. We went over a hook called useEffect, which runs the API only once. The issue right now is that this API is getting run over and over and over again, because what's happening is that whenever our state changes, we re-render. And whenever we re-render, it just goes through the entire code base again. And so every time it's just going to keep doing an API request, which makes our component really inefficient. And so the way you can get around that is we would do a useEffect hook. And then put the API request in there. And then we do a bracket here. Oops. Yeah. And so this essentially just means that that we will only run this API request once, which is at the beginning when the component first loads, and never again. So now if I were to load the page, I shouldn't, well, let me exit this. The current page is gonna have a lot of issues. Let me my laptop is dying from doing that example. So let me get back to here. Okay, so now everything is like okay. Now everything kind of loads just like normal. It's kind of hard to showcase like over like screen sharing, but if you tried that on your like machine, you would have noticed like how laggy it was earlier, and that was because it just kept calling the API over and over and over again. Okay, so I think that should go over a lot of what we did last time. And so now we're gonna move on to do like some more stuff. So if we take a look at the Pokemon generator, so this is like the actual Pokemon generator that we're trying to accomplish by the end of the series. And right, we have a couple stuff here. We have filter, we have this loading thing, but eventually this is our end goal, right? Our end goal is we're gonna have like this little canvas thing, and we have like, we can showcase the name, description, the Pokemon type, the move, each of the moves, and then as we went over in the database, right, each move has like a type, a name, and a power, right? So we kind of want to transition what we have here into like this. So the first thing to notice is that we don't really have a component for each like Pokemon section. It's all kind of just like basic HTML. So we're going to go ahead and make a Pokemon component, a Pokemon card component. So I'm going to do Pokemon card here. We'll make a JSX. I'll also make a style.css in here. So I'm just making a Pokemon card component. And then inside Pokemon card should just be import React from React. We're eventually going to want the style.css. Pokemon card equals then export default Pokemon card. And then you want to return something, right? Let's do that for now. Let's also pass in props. Okay, so this is like a very, very basic component right now, very basic Pokemon card component. And so our goal is we want to separate these Pokemon into different components. So the goal is we want to eventually be able to do this Pokemon card. And then if you remember how props work, they kind of serve as like attributes. So we eventually want to be able to do like name equals, I guess, Torchic, and then description equals like whatever, like this whole thing. So like I'm just gonna go like Torchic description. And then we want also eventually want to pass in the image, right? So let's just say we put in this. Okay, so this is our end goal. We want to be able to do this for each of the different Pokemon, like with Torchic, with Mudkip, and with Trico. And so now your exercise for the next like 5-ish minutes will essentially be to kind of just make the same UI that we just had, but with a Pokemon card component. So this will require some like knowledge of props, and yeah. So we'll spend about like the next 5-ish minutes in Discord doing this. Is the objective of this task clear? Like, does it make sense? Okay. Sorry, I haven't looked at chat, so I don't really know what's been happening. Okay, so I'll be on Discord, and yeah, we'll be on Discord.
Are we good to continue?
Okay. Everyone back? It should be good. Hopefully. Okay. Yeah, if y'all weren't able to like finish it, don't worry too much. Like I'll stay after like a couple minutes after the workshop so we can go over like if you have any issues with any of your code or whatever. Yeah, hide this over here in a second. Okay, cool. So hopefully you're able to kind of just get this that looks the same as this expected behavior. Oops. So okay, the next step now that we want to do is we kind of just want to link our API so that it shows, like it'll look like this, but with our API data, right? Instead of data that we hard code, it should look the same. So right now I just have something like this. So we can change it up. So let's do, okay. So we just connected the API data to our components earlier before this exercise. And body represents like the body of the object. So if we like want to take a quick look, you can click log Pokemon and it's just different Pokemon, right? Description, image, move, name, type 1, type 2. So let's go ahead and make our thing dynamic now. So now that we know what body looks like, we can create a component for each object in the array. So one thing we can do is we can do const current Pokemon, or Pokemons, we can do that, equals body dot map. So I'm just gonna write some stuff, try to follow along. Oops, not that. And oh, I guess in this case, body shouldn't be, I think body should be an empty, should be a, yeah, or an array. So body should be an array. So that was my bad before. It should be an array. It should not be an object. Start with being an array. So you can do body dot map. And for every single value,
Whatever you do.
we're going to return a Pokemon. So, and what we're going to pass into the Pokemon card is basically our props, right? Like name, description, image. So we're going to go ahead and do that. Let's do name equals, we can do the braces to indicate JavaScript. And we can do val.name. The same thing for description, val.description. What was the other one? Image, val.image. All right. And then we can also just go ahead and pass in like the other parts of our body as well, which I believe was, oops. We're gonna do like type 1 equals, I think it's called type 1. It's okay that we haven't used this in our like component because like it's okay to still pass it in. It's just like our component doesn't use it right now, but we should just pass it in anyways since we're gonna be altering the Pokemon card component to use this. I believe it's type 2, and then I'm missing something else. Let me double check this. I think I might be missing. Name, description, moves, name type 1. Okay, moves the other one. Moves equals val.moves. Okay, so I can go ahead and just, there you go. So, so this is how we get our current Pokemon or Pokemons, and we map each Pokemon to a Pokemon card. So now we can just one thing we can do is we can now just kind of put this in our components. So I'm gonna go ahead and comment out the hard-coded stuff. And I believe, let me double check that I'm not in the wrong place. Okay, it's fine. So here I can now just put current Pokemons. And if I compile that, we have a different set of Pokemon, right? And so on my end, I still have the old like mock data from last time, none of the database stuff. And so this is what it looks like for me. Like I have the Pikachu. If we look at the body, I have the Pikachu. I have the image. Snorlax doesn't have an image just because here the image is like just an empty string, so nothing's going to show. But yeah, it should look something like this. Snorlax goes move. Yeah, Snorlax flying would be such a sight. Okay, so yeah, so now that we've mapped the API body with the API body to a Pokemon card component, we basically have the view Pokemon page kind of done, except for like a couple of small features like filtering, for example. But for the most part, it's like basically done. So now what we need to do is kind of clean up the Pokemon card to look like what we want it to look like. And so here, so I linked the style, the CSS for the Pokemon card here. So I can just post this in chat again. But basically, if you can just grab all the CSS and just kind of put it in here. We're going to be using a lot of these like class names for certain styles. And so that way y'all don't have to like watch me type out CSS, and because I'll probably make an error somewhere and it'll be really annoying to deal with. So to make it easier, just copy it into Pokemon card style.css. And then now we're gonna go ahead and change up this component. So I'll give you guys like a minute to copy things over. Okay. Okay. So now I'm gonna go ahead and just start typing out the component, the card component itself. So just kind of like follow along and like type as I type. So we're gonna have a div at the main div. So class name equals, and we're gonna do Pokemon card, Pokemon dash card dash container. Yeah. And then we're gonna have another div inside here. Class name. Let me end this first. And do class name equals Pokemon dash card dash container dash inner. And then from here, we're gonna have a third div actually. So we're gonna have 3 divs, and then we're gonna do class name equals Pokemon card dash data dash container. I'll copy this in the chat so that like after typing this, in case if y'all want to like double check for like errors, because it's really easy to make a mistake here. And so inside this data container, we're going to set the p tags. So we're going to do class name to be Pokemon card dash name. And then it's going to be dynamic here. We're going to do props.name. And then we're going to do same thing, but for description. And then we're going to do something similar for types as well. But instead, we're going to add some more elements in here. Wait, let me put that. Okay, let me actually hide this a little bit so that in case that helps. So we're gonna have a span. Last name equals Pokemon dash type dash 1. And then we're gonna add a style here, but we're just gonna keep it really simple for now. We're just gonna do a black color. So in hexadecimal, all zeros just means black. So we're just gonna do that for now. And then, yeah, and then we'll also be doing props.type1. Okay. And then just copy that and then do the same thing here, but for type 2. So let me go ahead and copy this. So let me put that. Let me go and put this in the chat. Yeah, divs go burr, honestly. We have a lot of divs here. So now if we were to look at the page, let me see if it looks like how I want it to look like. Otherwise, this would be embarrassing. Let's go here. Yeah, okay. So it should just look something really basic like this. Yeah, something was beeping. I don't know where it came from. Yeah, something was beeping. I heard it too. I don't know where it came from. Okay, anyways. So it should look something really basic like this. So we haven't done anything with the image in this case because the image will come from like the canvas. But for now, we're just gonna have something like this. Should look something really basic. And in case you're wondering like how we got this to work, like the answer is just like a bunch of CSS, like all of the hard work to like make it look the way we want it to comes from the CSS, and the way, and like usually it just requires a lot of experimentation on the CSS side. Like we can go over like a little bit of like what the CSS does. Like we have like a container with borders with minimum width, minimum height, and like we use a couple displays. But like if you were to ask me like why we do certain things, it's really just like we just YOLO'd it and it looked good, which is honestly how front end works. Okay, cool. So yeah, so I'll just leave this up for a little bit, but I think we look good. Yeah, so unfortunately I wanted to like do a little bit more, but we are approaching 6 o'clock. So I think I'm just gonna go through like, I'm just gonna feel at the end what do we got here. Yeah, we can do the rest of the exercises next time, but yeah, so hopefully y'all were able to get that like small Pokemon card snippet done. So that's it for this workshop. We're gonna have one more workshop next week, and it's gonna be our last workshop. And so the goal of next week's workshop is just gonna be to try to wrap the Pokemon generator up and get our app deployed. So it's gonna be consist of both cleanup and deployment, which is gonna be really fun. So please come out next week. And yeah, if you're confused by anything, go to Henry's office hours. This recording will be on YouTube, so you can always check it later if you want to go back to see what we said. And yeah, Shreven, I don't know if there's anything else you want to add. I forgot.
We're good. Yeah, Daniel or Garrett, if you guys could post the solution code to the part 5 branch of the repo shortly after. And then yeah, recordings will be out in like a couple days. Mm-hmm. So yeah.
Yeah.
Thanks for coming, everyone.
Thank you, everybody.
Yeah, thank you for coming.
Thank you for coming out. We'll see y'all next week for our final workshop. Where the heck's my, I should stop sharing. Stop sharing. There we go. Okay. All right. Thank you. Yeah. Thank you. Yes. Nice.
All right, good stuff, Daniel.
Dude, I was like, oh, I'm gonna finish the code from before and then catch up later. And then Daniel just pasted all the stuff I worked on while I was going over it.
I'm so sorry.
Yeah, and I don't know both of them. This is just amazing.
Woohoo!
You got a lot going on.
I got a full blank white screen, so something's up.
Oh no.
We can work that out.
Woo! Yeah, Henry, I guess I'm going to your office hours. Hey, Lamau.
Got it.
Hey, Lamau.
Oh my god.
That's so
All
funny.
right. I'll see y'all later. Thanks for coming.
Yes.
Yes.
Okay, guys.